Hi, welcome to network interview preparation video. I hope you like it. Good to see you. Welcome to my channel.
Ladies and gentlemen, my name is Irvin, also known as Koboman. Today we're going to talk about the network administrator interview questions and answers.
Welcome to
And,
Top 20 Network Administrator
aha, there
Interview
it is.
Questions and
So,
Answers.
uh, basically, this is based off my video that I've made sometime last year about Top 20 Network Administrator Interview Questions and Answers. However, this video is only 9 minutes and 25 seconds, so I really wanted to expand on this to make it even easier to understand to somebody who's looking to get a job as a network administrator. However, this is also going to be very educational for people who are doing help desk, system administration, anybody who does tech support. Guys, we always learn something. Ladies and gentlemen, we always learn something new. I'm always learning something new. But this one is going to be just kind of expanding on it in the sense where you get more details and which will increase the chance of somebody getting a job. So it doesn't matter if you're watching this as somebody who's going to get into help desk, you can still learn a lot from this, you know. Okay, let's get into it. So what I'm going to do is I'm going to play the first question and the answer that I have listed under, and then I'm going to expand on it. All right, let me just pull up, what do I have to write? I don't have Office installed on this computer, so I'm just going to pull up a notepad. Let's just do that. All right, here we go. First
Not
question.
only will this video prepare you for this specific interview, but will also provide free IT education. Before we start, I'd like to thank all people that became members on my channel. Thank you so much. It's much appreciated. And to all that have interview coming up, I wish you best of luck, and let's get into it.
Can you tell us about yourself?
To answer this question properly, talk about your past experience in IT and stay away from irrelevant personal stuff. Stick to the facts about yourself, because if you say something that's not true, the interviewer may follow up with questions that you can't answer. All right, so this is very important because it's the very first question that they will always ask you. So here it is. It says, can you tell us about yourself? It should really say, can you tell us about yourself related to this job? But they will never say that. They'll just say, can you tell us about yourself, and keep it kind of open like that. So don't talk about irrelevant personal stuff. You know, talk about your past experience in IT and stay away from irrelevant personal stuff. Like, don't talk about your hobbies and what you do. Like, for example, in spare time, I watch TV. I like my favorite show is, I don't know, Game of Thrones, and I like to play video games. Stay away from all of that stuff. It's not related. They don't want you to tell them about yourself in that sense. You just want to talk about stuff that's related directly to this IT position, based off your past experience, whether it's job experience or education. You know. Now, if you have a hobby that's setting up servers or network switches and this and that that's related to this job, you can talk about that hobby as the last part of it. Always put your experience first. And this is why it says here, stick to the facts by yourself, because if you say something that is not true, the interviewer may follow up with a question that you can't answer. So don't glorify your experience, say what it is, because you'll get a question that you won't be able to answer. And of course, don't lie, right? Don't lie. All right, so here is how you can answer this. You can just use your resume. This is why I have Notepad pulled up. You can use your resume as a template on how to answer this. And always start with your current experience. So let's say you're currently working, I don't know, desktop support for company, let's say Google, and you started working there from 2019 through current, right? It's good to be currently employed. It gives you a higher chance of getting a job. So you can say, currently I'm working desktop support for Google, right? I started working there in 2019. Before that, I worked help desk and then provide a company name. I'm just picking a first thing that comes to my mind as just for an example. I don't know, Tata Consulting. And I worked there from 2017 through 2019, right? This is great. It shows that you worked for somebody else before and then you moved on to working from Google, you know, and then list older experience, meaning, you know, other experience that you have. And then if you don't have that, or you want to add more to it, you can say, or you can talk about your education as the next part. For example, you know, I have associate degree in network administration. Okay, and then say I have associate degree in network administration. I have a Net Plus certificate, and etc. So list all the other certificates that you have. There you go. That's all you need, right? So let's move on to the next one.
For example, if you say you have very good knowledge of working on a specific system, and yet you may have some general knowledge, they may ask you a very technical question that you may not be able to answer.
What is a firewall?
Firewall prevents a connection between two or multiple sources. It basically blocks any incoming or outgoing traffic. Firewalls can be in software or hardware forms.
What is
Okay, so we're gonna talk about the firewall real quick. If you wanna pull up firewall, it's on your computer, right? I feel like you should be able to pull up firewall. Here we go, firewall, Windows Defender, and security. Oops, I have it open without using administrator privileges. I think I'm gonna pull up advanced security, advanced Windows firewall security. So you can explain, I mean, if you're applying for network administration, you should know what the firewall is, but I want to show it to people who are wondering, what is network administration? What is this firewall? You know, I know a lot of people watching my videos are into that. So you got a couple of different firewall types. You got inbound and outbound. These are basically preventing, you can set them up to prevent inbound traffic, meaning data from coming in, connecting to your computer, and also outbound traffic, mean data being sent from your computer to somebody else. So if you create a new rule, for example, you want to, I don't know, what's the most common use of firewall, right? To block incoming traffic. But then there's also outbound, but let's do inbound. I think inbound is more common. So if we want to block a certain program for receiving, for example, inbound traffic, we can simply create a new rule. Here it is, and we're going to leave it at program. We're going to go next, and we're going to specify which program we want to block. So we're going to say, for example, I don't know, I'll pick a random here. I'm going to go to Internet Explorer. I'm going to block Internet Explorer from receiving. See, I can just select block the connection. I'm going to block all the connection, whether it's on domain, which is on the company network, or it's private at your local network, or if it's a public network, for example, you connect to Wi-Fi at the coffee shop. And I'm just going to name it blocked IE. I want to specify what it is so that way I can remove it later. Okay, and now IE is blocked for inbound traffic. That means it cannot receive any data coming in. No website can send any data. No other computer on the network, on the internet, nothing can receive any data that's coming through. Okay, so I'm just going to go in here and disable it, or I can just simply click allow connection, allow the connection, or in this case I'm just going to disable it. That means it's no longer being blocked, i.e. is fine now, or I can just delete it. So that's one example of firewall. This is at local level, at your computer local level. Group policy can apply these features at local level as well, so your computer will reboot or get a group policy update, and it would apply these local settings. May be here, may not be here, but they will be blocked, and that's fine. Same thing for outbound if you want to block any traffic going out. So that's a firewall. It's simply blocking data from coming in and out. So that's what that is. Here's this one. What is TCP/IP? I'm going to let it play.
TCP/IP.
TCP is a transmission control protocol that deals with establishing a connection between computers before any data is being sent. In other words, it acts as the highway for data packets being sent back and forth, used by various protocols like HTTP, HTTPS, or FTP. TCP also sorts out data packet receive order. Okay, so what is TCP/IP, which stands for,
Well, I had it in the video. Let me see here. Transmission control protocol over internet protocol is what it should say. So it's transmission control protocol over the internet protocol. And it deals with establishing connection between computers before any data is being sent. So without TCP IP working, you wouldn't be able to create any connections between two computers or anything. The networks would not work, internet would not work. So let's look at it at the local level. So if I go to my network adapters and go to adapter properties and look at this one here, okay, so let's look at the details here. It says Internet Protocol version 4, TCP IP version 4, and then you've got TCP IP version 6. Functionally, they work the same, except version 6 is basically allows for more IP addresses. So let's double click this. And here it is. It configures IP addresses for computers that are connected to the network, right? That's what it is. It's really, it stays here. You can get IP settings assigned automatically if your network supports this capability. Otherwise, you need to ask your network administrator for appropriate IP settings. So transmission control protocol is basically, well, let me show you this here. I really wanted to write it out, but here we go. Transmission means to transmit something, to send something. And then we've got, in this case, we're talking about data. And then we got a control. So it controls the transmission of data. It connects, it goes back together, right? And then it's protocol. It's just simply a protocol. It's a set of rules, right? And what that does in this case at local level is that it deals with assigning of the IP addresses. So here it says obtain an IP address automatically. So our computer will get an IP address that was just randomly assigned to it by the DHCP server, which is, if you're at home, it's your home router. So if I open up a command line and type in ipconfig/all, you can see that for this adapter, it says here, it says where it says Realtek PCIe GBE family controller, right? And here it is, Realtek PCIe GBE family controller. Let me put it right next to it, actually. You see that? That's the same thing. All right, and here's the IP address that it has, and it was obtained automatically and it was provided by DHCP server, which is the router, which is located at its default gateway, which is the same thing where the DHCP server is. So your router assigned it this IP address automatically based on first available. Okay, and same thing is done for DNS. Here is the DNS server settings, and it's at the same location where your router is. So that also provides your DNS information. DNS routing, I should say, domain name system. I think we will talk about that further in this video. And if you want to, assign an IP address manually, you can certainly do so. You just have to create create a static IP address inside of the DHCP server, and then say, okay, well, I'm going to have this computer use it. This is usually used for servers, where you manually change it to static IP address, which doesn't change. And you just fill this out. You fill out subnet mask, default gateway, and all that. So that's the simple explanation of TCP IP. All right, let me just close all of this, and then we're going to continue. I hope I'm making sense so far.
That back and forth used by various protocols like HTTP, HTTPS, or FTP. TCP also sorts out data packet receive order.
Can you explain the difference between HTTP and HTTPS?
HTTP stands for Hypertext Transfer Protocol, used by majority of websites that you use as means of transmitting website data, and it allows for use of hyperlinks.
This protocol mostly uses TCP port 80. However, HTTPS is a secure version of HTTP that allows for identity verification and low-level encryption using TCP port 443.
What is a proxy or proxy server?
Okay. Let's back up here. Difference between HTTP and HTTPS. I actually have a really good video which I'm going to just plug in right here with pictures and everything that explains that. So what are we talking about here? We're talking about websites, right? These are protocols used by websites, whether it's a plain website that you just kind of browse through or a website that kind of asks for your personal data, like when you're buying something, you know? For those reasons, you got to have two different versions of HTTP, which stands for Hypertext Transfer Protocol. So it's kind of in the word itself where hypertext, let's kind of start typing here, Hypertext Transfer Protocol. So I'm going to explain this where anybody can understand what this is after you watch this video. And I always talk about acronyms, meaning the letters. For example, HTTP. Well, what does it mean? You got to look at the words themselves first. So it means hyper. Well, hyper is just something that was added on there, but typically hyper means something that's fast. That's something that's fast happening. And then we got text. We know what text is. We're literally looking at it. And then we got transfer, which we know what the transfer is. You're taking something from one point and then you take it to another. And then we got protocol, which just protocol just means this is what this is. These are the rules. These are the rules that we follow when it comes to whatever this whole thing is. In this case, hypertext transfer is something, text transfer here is something that I want you to concentrate on because that's what it was initially designed for. It's to transfer text on over the lines, which are now known as the internet. So the first website was actually created by European Organization for Nuclear Research, also known as CERN. And I'll show you an example of that website, and here it is. Here it is. This is the very first website ever made. Supposedly, this is what they say. This is the very first website ever made on the internet. And you can see right now by looking at this icon here and literally the letters here, it says not secure. So what does that mean? That means that this website is not encrypted here, at least at this point, at this front end, at this time. So that means that there is no HTTPS. And that brings me back to what we were talking about here, between difference between HTTP and HTTPS. If you add S at the end, it just means secure. Secure, and also means encrypted. Encrypted, hidden, if you will. Right? So that's what that means. Now we know what Hypertext Transfer Protocol is, what it does, and that we know that by itself is not secure. However, if you're using Hypertext Transfer Protocol secure, then we know that it's encrypted. And I will demonstrate this by viewing the packets. So even though we're going to start talking about viewing packets, packets are basically data that are transferred or sent back and forth from your computer to whatever is on the internet. In this case, we're going to talk about a website. So we're going to look at the data, which are also known as packets, that are being sent from my computer to the website, and the packets that are sent from the website to my computer. We're going to look at that. And I was actually going to start drawing here, is what I'd usually do for a shorter version of videos that explain this type of stuff. But in this case, I actually wanted to demonstrate to you how it works. So here's our website. We're going to keep it up here. And I got another website that we can test with to show you the difference between HTTP and HTTPS website. And we're going to monitor packets. Again, the packets are the data that's being sent from my computer and received from my computer to the website and sent by the website. So all the packets, sort of like mail. Think about when you're sending mail back and forth, and I'm talking post mail, not, well, just for the sake of explanation, imagine a post mail being sent as literally physical letters. You send one over there and it comes back, you know. Of course, you know, internet mail works the same as the website when it comes to, in the nutshell, when it comes to sending data packets back and forth. So this is why it's called web mail, because it's derived from sending those packets back and forth. I'm assuming that's where the naming scheme comes from. So here we have a network analyzer, which is called Wireshark. And I'm not saying you should go ahead and install this because it's up to you. You know what I mean? It's not something that I'm sponsored by. These people don't sponsor me or anything like that. So it's up to you if you want to play around with this tool. Excuse me. I'm using it here for the demonstration purposes only. So we have Wireshark, and it's a network analyzer that will allow me to read all these packets that are being sent back and forth. Remember, we just talked about them. You know, I send one packet that way. My computer sends one packet over there and it receives another. You know, that's also known as a handshake in networking terms. So in this case, we got to tell Wireshark which data do we want to monitor from what. And I'm going to say here the Ethernet here, and we can see that there is already some activity going on. But I'm going to tell it to specifically monitor my local area network, which is where my internet cable is connected, but it's also known as Ethernet locally. But, you know, I'm connecting it to connect to the internet, although it's called Ethernet at local level. But we're going to select that adapter to monitor. So whatever you plugged into, or if you have a wireless connection set up, make sure you select that if you want to monitor that specific packets to specific packets. So I got it selected right now, and Wireshark starts to monitor everything that's going on right now, and this means going over all kinds of different protocols. And don't be scared when you see this right now. Okay, this is normal. What you're looking at is a totally different protocol, which I'm just going to tell you what it is. If I just kind of pause the data here, you can see that data is going over RDP, which is Remote Desktop Protocol, over UDP, which UDP handles the data being sent back and forth. RDP, which is Remote Desktop Protocol, handles the connection between two computers that are using remote desktop. And that's what I'm using right now. I'm actually using remote desktop, and you can see that these two IP addresses are on the same network. So the data, so if I scroll down, you can see there's a lot more data, but data goes back and forth. It's a two-way street, right? I send one packet and I receive one. And the same thing is displayed here. You can see a source and then you see a destination. And then in this case, we see that one source. In this case, I believe this is my main computer, and the 103 is the one computer that we're looking at right now, which is the computer that I'm using, that I'm connected to using RDP, Remote Desktop Protocol. And you can see it goes back and forth, because remember, it's a two-way street. You got to send one packet and then receive another one. This is how communication starts, and this is how communication happens, and this is how the data is being transferred. If one of them doesn't go through, then this whole thing breaks, right? And we can see here that if I do IP config /all, we can see that the IP address of my computer here, which is the remote computer, is 103 here, right? 103. So let's find that over here. And here it is. It's 103. Right? And if we select it, of course, we can read all the data. So now we know what kind of traffic we're looking at. Now 103 is this computer that I'm literally using right now, and it's receiving information from 104, which is my other computer on the same network, right? And I'm just remoting into it. Okay, now let's continue with HTTPS. And HTTP, I should say. So we're going to filter we're going to filter for HTTP traffic here. I'm actually going to reset it. Okay, we're going to reset it. And then I'm going to refresh this page, which is not secure. Remember, this is the very first website ever made. I'm going to do a quick refresh so we can see the data sent back and forth. All right, and we got a response right away. And since it's not encrypted, when we select on any of these responses, we're going to see more details on the bottom, which we're going to talk about. So again, here it is, the same type of deal. I am sending a request to connect from my main computer. Remember, we just looked at that. Here is 103. I'm sending a request to connect to this destination computer, this destination IP address, which is the name of this website. Here it is. We're going to copy it. Right, we're going to copy it and double check this. We're going to do command line, right? We're going to type in ping. We're going to paste the name of the website. Actually, let's do a, well, I was going to clear the whole thing, but we still need the IP config stuff. So we're going to ping it. We're going to see a response from it. I'm sorry, I should have pinged, I copied the whole HTTP thing here. But actually, why, I just need the domain name, which is info.cern.ch. And here it is. And here's that IP address that we just saw here. It's 188 and then .184.21.108. And here it is. Sure enough, we sent a packet to this destination, which is reflected here, right? And then we received a packet from it to my computer. And that's how packets are sent back and forth. And the reason we can see this right now in detail, if I select any of these, is because it's just using HTTP and not HTTPS. That means that it's open for everybody to see. So let's look at what's going on here. And we're going to concentrate on, let's concentrate on the one that's on the received packet from the source. It's from the website. So let's see what kind of data we can see here. And I promise you, this is not going to be confusing at all. You know, I'm actually known for explaining things in an easy manner. So here's some description we hear. The first line that we see here, it tells you the size of the packet that's being captured and it's being sent back and forth. And it tells you on which interface. And this is the interface description, I should say. All right, it's ID 0, which is the one we selected. Remember, we selected that local area network first one, which was the Ethernet adapter, right? And then it kind of tells you a description of it. It says Ethernet 2, and then we can see the source, which in this case, since if we look at it carefully, the source here that we selected is actually from the website, and the website itself is using a Belkin type of network adapter, and then destination here is micro ST, which is my local adapter, and it gives you some data here. And what that looks like here is the MAC address. MAC addresses are unique to each piece of hardware that is in the world, right? So we're here talking about my Ethernet adapter. Remember, we plugged it in, we selected it, and it gives you data on that. But not just that, but also from the source, right? This is the source, and this is where this source is using. So right now we can tell already that this is exposed, right? We can see the MAC addresses here. And then we can see which version of Internet Protocol we're using here. And then this is Internet Protocol version 4 for both of these computers that are communicating. So it's IP version 4, right? This is a standard that's been around for a long time. Some companies are switching to IP version 6, which the IP addresses look way different than this here, but this is what we're using here. These are IP version 4 type of IP addresses. So we got the source one again, and then we got the destination one again, right? And then it talks about, in the next line, what's going on, what kind of communication. Remember, the first example we saw was remote desktop, and it says RDP, UDP, right? And then in this case, it tells us that it's actually TCP, which is Transmission Control Protocol, that received data from port 80, which is the source. SRC means source, port 80, which is the HTTP protocol for the internet. For the website, HTTP uses port 80. And then we've got destination port, which here is 53650. That just means it's transmission control protocol over UDP. And don't worry about that right now because I don't want to get into too much of detail here. But I just want you to know that this was the incoming data was handled by a local transmission control protocol over UDP, which handles the data that's being received. Okay, and then it gives you just a plain description of what this was, and it just says hypertext transfer protocol. Okay, I've went ahead and reset Wireshark. Now we're going to go to a known website that has encryption. Here it is, google.com. We can see connection is secure, it's encrypted. So far we're not seeing any data coming through. Let's do a refresh just to make sure nothing's happening. Let's start browsing. Let's go to news. You know, scrolling down, we can see there's a lot of stuff there, but we're not seeing any packets, right? Why? Because it's encrypted. The connection is secure. It's using HTTPS. You don't believe me? Well, let's go to another website here. Let's go to yahoo.com. It's encrypted. Connection is secure. There's a bunch of stuff, even ads. Sometimes ads show up as running an unsecure version, which is just HTTP or something else, and that data will might show up, right? So right now, even ads are encrypted that we see on the right side there. All right, well, let's go to, I don't know, youtube.com. All right, same deal. We don't see anything going on. Refresh. No data so far. And just to prove it to you that we are not cheating here, I'm just going to go back to that same website. Matter of fact, let's go to washington.edu. This is a website where it has a front page that's not encrypted. You can see it's not secure. And then, boom, we have all the data that's coming through because it's not encrypted, right? I know for a fact that Washington EDU has encryption. If I start to go further, for example, if I go to About section, we suddenly see that it's encrypted. So if I do a refresh page here, well, actually, let me reset what we were monitoring and recording. So if I go to here, well, see some of the parts. This one is actually give you a denial. Right? Look at this right now. All right, so that's cool. It's requesting some of the connection requests on the HTTP because we're probably still requesting on regular HTTP protocol without the secure, but it's actually denying that. So it's being rerouted to the encrypted version, which is the HTTPS. So if I go to here, this and that, this website really needs to change their front end to be encrypted as well. It wouldn't hurt anything here. And I'm just going to reset here. Here we are. This is the washington.edu /news. And this one is completely encrypted. There is no rerouting happening. So the reason it came up that one time is because it was simply getting a request for HTTP. And it was saying, no, we want you to use HTTPS. So that is your explanation right here. That's the difference between HTTP and HTTPS. Now, can I set up Wireshark to monitor traffic that's HTTPS? Yeah, that's possible. I would, need to do some setting up, and we can see what's going on, but it's going to be encrypted. And for those reasons, whenever you see an ad, somebody promoting a VPN that says make sure web browsing secure, well, all the VPN does is it routes you to a different network, and that network actually might read your data just like I'm reading it, right? They can read your data because they can intercept it. This whole point of this video is to help you understand of what's going on here. However, if you're not worried about the source or where your location is, for example, if you don't want other websites, other apps that you're trying to connect to, that you are trying to use. If you don't want them to know your IP address, then you might want to start using VPN. But using VPN doesn't make your connection more secure. What makes your connection more secure is going to websites that are secured by encryption using HTTPS. So even if I go to do a search here, I'm sending data. I'm going to say, I don't know, what is this website about schooling, right? I'm going to do a search for class. I just sent the data to it. I just sent data to this website, right? You understand? And it gave me results, but nobody else can see it. Even if they could see it, it's encrypted. And right, I got the results. I successfully sent data to that website. So the same deal, if I'm trying to log in, I don't know if there's a login here somewhere, but if I was to log in and I put my login ID and password, it's safe. You don't need a VPN for that. So whoever, next time you see a YouTuber advertise a VPN and they say your data is secure, it makes your browsing safe, no, it doesn't. Okay, you can still get hacked, you can still get viruses. It's all about you. You're the main person who is going to protect yourself by using your brain, your knowledge, your common sense. And education is number one. This is why I always give this stuff out for free, this type of education, and I make sure that it's easy to understand.
What is a proxy or proxy server?
Proxy deals with filtering network traffic in a sense of preventing access to certain websites, and it can even monitor user web activity. To put it simply, it can block certain websites from being accessed, but can also act as a measure of hiding the true origin in point of access. Okay, so what is proxy? It's kind of similar to Firewall, but it just blocks websites. And this is, I don't know why I opened the Edge. I didn't want to do that. Internet settings. So if you go to Internet options on your computer and go to connection and then go to the LAN settings here, you can see that there is a setting for proxy. And here it is. It's actually set up already here as an example. I really should have disabled this, but since this is not really affecting my computer at this point, what really should be happening is this. Automatically detect settings. That's by default. But if you have a proxy server on your work computer, look this up. Open this up and you'll see that there is, a proxy. If it's a big company, I don't know, maybe you don't have it. But proxy just filters traffic, basically allows you to access certain websites and blocks certain websites. So if they don't want you to access some of the sketchy websites, you know what I'm talking about, then they can block it. So that way you'll just get a warning, hey, you shouldn't be going here. But they can also block things like YouTube and such, like, social media stuff like Facebook. Basically anything you can think of, any website, they can block it. So that's what proxies are used. And proxies are controlled by servers. Let me see here. Since a lot of traffic goes through a proxy server. Why did I pull up snipping tool? I did not. It's the same, kind of similar icon as to paint. Let me see if I can get paint up real quick. So it's usually you got proxy servers that are like multiple proxy servers because there's a lot of data going back and forth. They're filtering. It has to go through them before you reach the internet. So, a big company can have a lot of traffic coming through, which can slow these things down. So you have a proxy server number 1 here, P1, and you got P2, P3, and they're all connected. They're connected for load balancing. Let me type it here. Load balancing. So it's literally what it says here. It's for load balancing, and well, I guess I can type it here, can't I? Yeah. Load balancing. So here it is. They're set up in load balancing so that the traffic can process in a way where it doesn't slow down the usage of the network, of the internet. So while it's blocking all the websites and this and that, they're balancing themselves. So if P1 has 100% utilization, meaning it's 100% being used, then that's bad, right? But that's okay. We got load balancing. So instead of 100, it's going to be, I don't know, depends on how it's set up. Let's say 30% here. And then if there's more than, whatever the settings, whatever threshold is, you may have like 20% on P2 going, And then maybe, I don't know, 10% on this one here. And, just so it's easier to process. Okay, let's move on.
Can you explain what UDP is?
All right, so the next question is about UDP, and we can certainly talk about this as well, but at this time I'm just kind of feeling for to see if people are interested in this type of content. And this is not going to replace my help desk video as well. This is just kind of in addition to provide a little bit more and a little bit more variety. Also, I happen to be on vacation when this video comes out, so I just wanted to make something so you guys are not left out without a video. I wanted to provide something educational. I know it's probably going to be like 20 minutes long, but this is what I can provide at this time, because I'm on vacation. I got to take a break. But yeah, those help desk videos will continue. If you want to let me know if you like this, please leave a comment below. I also would appreciate a like on this video. That's another way to tell me that you're interested in this type of stuff. All right. Thank you so much, and I hope you have a wonderful day. Bye-bye.